Welcome back to Soils 446, 546. This course is Drinking Water and Human Health. This is lecture number 29. In this lecture and the next lecture, lectures 29 and 30, we'll be talking about a relatively new area in drinking water. And this is the topic of pharmaceuticals and personal care products that are considered PPCPs and how they impact drinking water. Before I go into much detail, I need to let you know that this is really a new area and we don't know a lot about the impact of these type of products on human health and drinking water. So what are PPCPs? As pollutants, they refer to any product that is used by an individual for personal health or cosmetic reasons or used by agribusiness to enhance the growth or the health of livestock. PPCPs are a diverse collection of chemical substances that include, first of all, prescriptions, over-the-counter therapeutic drugs, veterinary drugs, fragrances, lotions, and cosmetics. So this is a large class of materials, thousands and thousands of different materials. Let's take a look at the sources of PPCPs in the environment. First of all, human activity. We bathe, we shower, we swim, and we've used a lot of these personal care products, and they wash off our bodies. And that's how they enter the environment. People taking illicit drugs. They move through a person's system and then into the environment. Veterinary drug use, antibiotics and steroids as part of keeping animals healthy and or productive. Agribusiness. Residues from pharmaceutical manufacturing. They end up in the environment. And then we also have to consider residues from hospitals. They also have an impact. So in general, PPCPs are everywhere. They get into the environment by many, many different means. People contribute PPCPs to the environment when their medications, their medication residues pass out of the body and into the sewer lines through urination, defecation, things like that. Medication residues pass out of the body and into the sewer lines. Well, our wastewater treatment plants are not equipped to take care of residues of PPCPs. If we externally apply drugs or personal care products, such as lotions, they can be washed down the drain when we wash. And what about the unused or expired medications? When we're finished taking a medication and we still have some left, how do we dispose of it? A lot of people just put it in the trash. Those residues can leach out of landfills or other ways we get rid of them and enter the environment. The discharge of pharmaceuticals and the synthesis materials and byproducts from manufacturing, they're well defined and regulated. So the pharmaceutical industry that manufactures these products and their byproducts from manufacturing, the manufacturers are very regulated as to how they get rid of their residues. So they're really not the problem. The problem is the end user. So this is a huge group of products. Why do we even talk about it in this class? So what's the scientific concern? Well, first of all, pharmaceuticals are widespread in our nation's waters. In the last 15 years, scientists have been looking for pharmaceutical residues in drinking water, and they have been finding them in very low concentrations. Now, these pharmaceuticals may not directly have a negative impact on humans if we come in contact with them in drinking water at their low concentrations, But there's some research out there that suggests that certain drugs, when released into the environment, can cause ecological harm. And that's one of the reasons we're concerned. So we really need more and better research to determine how important of a problem are PPCPs in our water systems, not only from drinking water, but from an ecological standpoint. To date, there is very, very little. I say no, but there's a little bit. There's virtually no scientific evidence of adverse human health effects of PPCPs in the environment. But that doesn't mean there are negative impacts. There's just so many personal care products, and so few of them have been studied, and their concentrations in waters are very, very, very low. So we just don't have any threshold data. So if there's no scientific evidence to date that shows that these products adversely impact human health if consumed in drinking water, why should we be concerned? So what are our reasons for concern about these products? First of all, large quantities of PPCPs can enter the environment after the use by individuals or domestic animals. So large amounts of these materials can enter the environment. Secondly, wastewater treatment plants are not equipped to remove PPCPs. So unlike other things, organic compounds such as feces and food waste and pathogens, wastewater treatment plants can get rid of them. But wastewater treatment plants are just not equipped to remove these PPCPs. In addition to concerns about humans, there are potential risks that some of these PPCPs pose to aquatic organisms. So the risks right now posed to aquatic organisms are virtually unknown. There's some anecdotal information, but basically we don't know much about the risks. The risks posed to humans are also unknown. Well, we really don't know anything about the risk to aquatic organisms and to humans. We know that the number of PPCP products used by humans and agribusiness continues to increase. So more and more products are out there all the time. Some of the products we take are antibiotics and steroids. Now we actually widely find these antibiotics that humans take and steroids are now widely found in the environment. As a matter of fact, well over 100 individual PPCPs have been identified in drinking water supplies. So we have all these chemicals that we don't really know much about. And that's why we're taking a little time in lecture, because although I've got very little data to show you today, I think that in the next 5, 10, 15 years, there will be a lot more interest in these products. I know that I do a lot of outreach work in the Pacific Northwest, and one thing that people always ask me about are pharmaceuticals and personal care products in the environment. And my big problem is finding experts to actually address these topics, because the amount of data out there and our understanding isn't very good. So what's the risk of these PPCPs? First of all, let's look at it. The truth. No one really knows. So it's an unknown right now. So this is kind of the cutting edge of drinking water science. We don't really know anything about these chemicals. We don't really know how they impact human health when they're found in drinking water, but we need to find out. And then I guess the next thing is, where are PPCPs found in the environment? Basically, we know that we can find these materials in any water body that is influenced by raw or treated sewage. Raw sewage would be human and animal waste. If they had PPCPs, steroids, antibiotics, they'd be in the water, and even any treated sewage, which means it probably comes from urban areas. Wastewater treatment plants can take out most harmful things, but they aren't equipped to take out these PPCPs. So these personal care products, pharmaceuticals and personal care products, are found in rivers, streams. We see them in shallow groundwater. We see them in coastal marine environments. And now we're starting to see them in many drinking water sources, although in very, very, very low numbers. So we tried to get an estimate of how much PPCPs, pharmaceuticals and personal care products, are discharged into the nation's waters. And on an annual basis, the best number I could find in the literature is about 271 million tons of these pharmaceuticals and personal care products are discharged into the USA's waters every year. 90% of this discharge into our waters is legal. So we need to do something about this 90%. Since it's legal, we need to look at fronts like public education. We need to look at alternative disposal strategies. There's a lot that we need to do. The first real work on PPCPs was conducted by the U.S. Geological Service. They did a study that was conducted between 1998 and 2000. And they were trying to get a handle on what's out there in the nation's waters. Their study found that a broad range of pharmaceuticals and personal care products commonly occur in waters downstream from areas of intense urbanization or animal production. So rivers downstream of cities and downstream of animal production because of the antibiotics and all the chemicals we use in the production of animals. At least one pharmaceutical and personal care product was found in 80% of the waters that the USGS sampled, which means that pharmaceuticals and personal care products are widespread in our nation's waters. They also found that pharmaceuticals and personal care products can occur in low concentrations in streams that receive both untreated and treated wastewater, and that goes in hand with what I mentioned a little bit earlier. Downstream from urban areas, downstream from agricultural areas. Okay, so now we know, based on surveys by the U.S. Geological Survey, that 80% of the waters in the U.S. probably have traces of at least one pharmaceutical and or personal care product. So what kind of compounds are they actually finding? We move forward to a study that was done in 2006 and 2007. And this study looked at 19 public water systems, and they found 11 major compounds in drinking water supplies that they could readily identify. So they found 11 major compounds in drinking water. But what was really important is that 10 of the 11 compounds commonly found were pharmaceuticals and personal care products. That meant that only one of those compounds they found in the drinking water was not a pharmaceutical or a personal care product. And that one was a pesticide, a herbicide actually. So let's just take a look at the names of a few of the pharmaceuticals and personal care products that we commonly see in our water supplies. Atenolol, it's a beta blocker. People take it as a beta blocker for health reasons. Carbamazepine, it's a mood stabilizing drug for people with bipolar disorders. So people take it, it goes through their system, and enough people take it so that we see concentrations of this compound in our water supplies. Estrone, This is a hormone that's people take. It's a hormone that has been blamed for causing gender bending changes in fish, male fish to become female fish. This is the one compound that they think does ecological damage in the environment. So far, we don't know that estrone has caused any problems in human health by consumption in drinking water. But I'm just kind of showing you a range of compounds that have been identified, and we're talking about pharmaceuticals and personal care products. I can't pronounce these compounds, I'm sorry. Gemfibrozole, it's an anti-cholesterol drug, widely used by humans, found in many drinking water systems. Meprobamate, it's a tranquilizer used in psychiatric treatment. And that's floating around in our waters, again, but at very, very, very low concentrations. Naxprozin, it's a painkiller and an anti-inflammatory, taken by a lot of people. Enough residues, get in the environment, get into water supplies, and several public water systems. We found this compound, although in very, very, very small concentrations, well less than a part per billion. Should we be concerned about it? We don't know. The research hasn't been done. Phenytoin, it's an anticonvulsant for epilepsy. Another pharmaceutical, another product people take for their health. Again, found in several drinking water supplies, but at very minuscule concentrations. And I just want to list a few more compounds that have been found, pharmaceuticals and personal care products that have been found in our drinking water supplies. And I want you to think about these as we move into our next lecture on pharmaceuticals. I'm just trying to give you the range of things that we're actually seeing in supplies that turn into our drinking water supplies. Sulfamexiflozole is an antibiotic for strep. Widely taken by people, gets into our water supply. TCEP, it's a reducing agent used in molecular biology. So it's a chemical that's used in a laboratory, yet the residues get out through the water stream and end up in water supplies that may be our source of drinking water. And then finally, the last one that I just wanted to mention is trimethylprim. This is an antibiotic. We find lots of antibiotics at very low concentrations in water supplies. So these are all pharmaceutical and personal care products that people take for a reason. Lots of people take these products. They go through a person's system, flushed out through excretion processes, and we end up with trace amounts of these chemicals in the water supplies, and some of these water supplies become our drinking water. The concentrations of these chemicals are very, very, very low. We would suspect that they do not cause problems in human health, but the problem is the research has not been done to confirm that they are not problems at the level of concentration they're found. And the other issue is, do they have an ecological impact out in the environment? And very little of that has been studied. The one thing I mentioned was a chemical that might be linked to gender bending in fish in streams. So thank you for your attention. We will consider talking about pharmaceuticals and personal care products in our next lecture.